Hello folks, this is Mr. Habel. I'm here with some of your teachers, KJ.
Woo.
I decided to be the movie star simply because I'm better
Good
looking
looking,
than KJ.
right.
The goal of this lab is to try to figure out delta H, the heat of combustion for burning magnesium. I'm going to do that right now
Safety goggles.
and put it in the flame.
Really? You're holding your goggles?
I am. And
Pretty.
it's very bright, so don't stare too long because it'll hurt your eyes.
Are you going to damage my camera?
I don't think it'll damage your camera because I have people doing this, but I'm not looking at it. I'm kind of looking off to the side.
I'm focusing on your eyes right now.
And now it's done. So what kind of reaction is that? Is that exothermic or endothermic? Well,
I know.
Talk to me, KJ. What kind of reaction is it?
I'm not telling.
It's about as exothermic as can get, right? It's very, very hot. So hopefully you knew that was exothermic. So what is the sign of delta H going to be?
I know.
It is going to be?
Negative!
And not only is it going to be negative, it's going to be negative and big, right?
Big
That's
negative.
a lot of heat being released.
Oh, I would like to say that it's going to
Yes.
be lots of KJs.
Ah, very good. I hadn't thought of that.
Okay,
KJs,
sorry.
lots of kilojoules. Very good. So how do we figure out delta H? Well, we can't really do that reaction in a calorimeter, right? It's too hot, and we have to. Our cheap calorimeters use water.
Water, that would put it out.
It would put it out. Actually, I don't know if it would. Should we
I
try?
don't know if it would.
We instead use Hess's law. We're going to do 3 other reactions. Actually, we're going to do 2 reactions, and I'm going to give you the delta H for the third. Your job is to add up those 3 reactions to get the final reaction for the combustion of magnesium, and then you'll add up delta H's to get delta H for the combustion of magnesium.
Awesome.
So I'm going to do the first reaction now, and then we'll do a second video of the second one. So the first reaction is HCl, hydrochloric acid, which we have here, plus magnesium oxide, which is this white powder. I've got a little data table, and the data table says the mass of the HCl. Now, this is hydrochloric acid. It's 1 molar HCl, which is pretty dilute. So most of this is water. There's not that many HCl molecules in it. We're going to make the assumption that since this is mostly water, the density of this is going to be the same as water, and the specific heat is going to be the same as water.
Is that really accurate?
I think it's going to be accurate enough. So here I've got 100 milliliters of this HCl, which I'm going to assume is going to have a mass of 100 grams.
Okay, we have to pause because you have to put on your goggles. Right now, I'm serious.
I got glasses on.
Who cares? So did Beckman. Oh my gosh.
All right,
Okay.
so we're going to pour this into the styrofoam calorimeter, and I'm going to take the initial temperature, and I'm going to record this in my data table. And it looks like it's going to be, looking through 2 sets of goggles because of KJ, 23.1 degrees Celsius. I'm
Write
gonna
it down,
write that
nerds.
on my 23.1 is my degrees Celsius is my initial temperature. Now I've also got the mass of my magnesium oxide. I said weigh out about 1 gram. I've got a little bit more, so it's 1.22 grams. I'm going to write that down.
Write it down, nerds.
1.22 grams, and I'm going to dump that into my calorimeter, stir it gently with my thermometer. Now this is a slightly exothermic reaction, so the temperature does go up a little bit, but not all that much. Right now it's at 24.5, right now it's at 25. I'm going to let it go just a little bit while that acid has a chance to react with the magnesium oxide. Now once we do this, we're going to figure out a final temperature. You're going to figure out delta T. You'll have to use our heat and specific heat equation to calculate how many joules went out from that reaction into the water. And then you're going to have to divide by moles of MgO to get delta H for the reaction. So right now it's at 32, still climbing a little bit. I think it might be close to plateauing. We're going to say it's at 33.4 degrees Celsius as our final temperature.
You could have told us a joke and then checked it again. What number was it, did you say?
I said 33.4. Yeah, I think it's staying right about there.
33.4, nerds. Write it down.
Okay, so you have the mass of the HCl, you've got the mass of the MgO, you've got the initial and final temperatures. Your job is to figure out delta H for that reaction.